Hello. In this practice lab, I will configure the network with OSPF. The network is configured with both IP version 4 and IP version 6 on all devices. This will allow me to implement routing in both OSPF version 2 and OSPF version 3. In addition, I will configure both versions of OSPF in multiple areas. Before you start this lab, when you download the packet tracer source files and walkthrough documents, run the show command on all devices. This will give you an idea what has been configured, and also run the command show IP interface brief and show IP version 6 interface brief. And on the internet router, run the command show IP route and show IP version 6 route, because I configured already on this router static routes. I hope my videos are helpful for those who are seeking to be Cisco certified. If you like my videos, please subscribe to my channel and recommend it to your friends. And share it on your Facebook page and give me the thumb up. And please let me know if you have any suggestions, comments, or questions. I will gladly answer you back. On the description of this video, you will find two files, one for the packet tracer source files and the documents to walk you through the lab step by step until you finally will be able to verify the configurations you did during this lab. I will configure default static routes on router 0. I will configure IP version 4 and IP version 6 default static routes, and I will use the exit interface in my configurations. So now on the router 0 here, enable the command configure terminal IP route to any network with this subnet mask, the exit interface on serial 010 and IP version 6 route, the same exit serial 010. Next, I will configure a single area OSPF version 2 on router 0, router 1, and router 2 in area 0. So now on router 0, we are still on router 0. The process ID of 10, I'm in the global configuration, router OSPF process ID of 10 for all the routers in today's lab. I will activate routing for the appropriate networks, and I will use inverse masks that specify only addresses within the networks. I will configure only the links to router 1 and router 2 because we configured the link with the internet router with the default route. Now the two networks, network of 10.10.10.0 with the inverse subnet mask of 0003, and this is in area 0. The other network of 10.10.20.0 with the inverse subnet mask of 0003 in area 0. Next, I will specify a bandwidth value that matches the clock speed of the interfaces of router 0 for interfaces of all devices that are configured in area 0. So I'll exit from here. On the interface of serial 000, the bandwidth of 128, and on the interface of serial 001, bandwidth of 128. Enter. Next, I will set the router ID on router 0. I'll exit from here and go back to the router OSPF 10, and now we can specify the router ID on router 0 of 10.20.0.0. We will have received an error, just not to worry about it. Enter. Next, I will configure OSPF version 2 on router 1. So we are done on router 0 here. Now on router 1, enable, configure terminal, router, OSPF 10. I will activate routing for the appropriate networks, and I will use inverse masks that specify only addresses within the networks. So now I configured already the interfaces, but let me show you the networks we will specify here on router 1 with this simple command. Do show IP route connected. This will list for us the networks are connected to router 1. Now I will network of 10.10.10.0 with the inverse subnet mask of this, and this is in area 0. This is the link with router 0. The other network of 172.16.10.0 with the inverse subnet mask of 0003, but this is within area 10. And the other network of 172.16.4.0 with the inverse subnet mask of 0003, and this is also in area 10. Enter. Next, I will specify a bandwidth value that matches the clock speed of the interfaces of router 1 for interfaces of all devices that are configured in area 0. I'll exit from here. Now we have on the interface of serial 000 the bandwidth of 128. Enter. Next, I will set the router ID on router 0. Exit. Router OSPF 10. Now router ID on router 1 of 10.0.0.0. Enter. Next, I will configure single area OSPF version 2 on router 2. We are done with router 1, now with router 2 here, this guy. I will use the process ID of 10. Enable, configure terminal, router, OSPF process ID of 10. Next, I will activate routing for the appropriate networks, and I will use the inverse masks that specify only addresses within the network. So again, let's see what networks are connected to our router here, router 2, with the command show, do show IP route connected. Sorry, do show IP route connected. And here, as you can see, it lists for us 3 networks. One in area 0, which is the link with the router 0, and the other 2 links in area 20. These 2, 20, and this one in 0. Back to router 2. So we have the network of 10.10.20.0 with the inverse subnet mask of this. This is in area 0, and the other network of 172.16.20.0 with the inverse subnet mask of 0003. This is in area 20. And the other network of 172.16.20.4 000.3 inverse subnet mask. This is also in area 20. Next, I will specify a bandwidth value that matches the clock speed of the interfaces of router 2 for interfaces of all devices that are configured in area 0, which is our interface of serial 000. Bandwidth of 128. Enter. Now I will set the router ID. I'll exit from here, router OSPF 10. Now I can configure the router ID of 20.0.0.0. Enter. Next, I will configure a single area OSPF version 3. I will configure the OSPF version 3 on router 0, router 1, and router 2. So we will go back to our guy on router 0 to configure IP version 6. Exit from here. Now, again, I will use the process ID of 10 for all OSPF version 3 processes. IP v6 router OSPF 10. Now, because we did not configure IPv6 unicast routing, that's why we had this error, or it's not enabled. Now we can run the command IP version 6 route OSPF version 10 and then hit enter. Next, I will activate routing for the appropriate networks, but first I will set the router ID on the router. And I will not activate the network connected to the internet because we already configured default static route. Now, router ID of 10.20.0.0. Exit. Now, on the interface of serial 000, IP version 6 OSPF with the process ID 10. This is in area 0. On the interface of serial 001, IP version 6 OSPF 10 in area 0. Enter. Next, we are done with router 0. Now let's move to router 1 here. Exit. Now, once again, I need to enable IP unicast routing, IPv6 unicast routing on router 1. I will use a process ID of 10, IPv6 router OSPF 10. I will set the router ID of 10.0.0.0 for router 1 with IP version 6, hit enter. Next, I will activate routing for the appropriate networks. I'll exit from here. Then on the interface of serial 000, the interface facing router 0, IP version 6 OSPF 10. This is in area 0. On the other interface of serial 001, IP version 6 OSPF 10, but this is in area 10. The other interface of serial 010, IP version 6 OSPF 10, and this is again or also on area 10. Next, I will configure router 2 with the OSPF version 3. Now on router 2, I'll exit from here. First, I will enable unicast routing, IPv6 unicast routing. I will use a process ID of 10, IP version 6 OSPF IPv6 router OSPF version 10. Process ID 10. Next, I will set the router ID. Router ID on router 2 of 20.0.0.0. Enter. Next, I will activate routing for the appropriate networks. I'll exit from here. Now, on the interface of serial 000, the interface facing router 0, IP version 6 OSPF process ID of 10 in area 0. The other interface of serial 001, IP version 6 OSPF 10 in area 20, and the other interface of serial 010, IP version 6, OSPF 10, also in area 20. Now, we are done with this portion of the network. Now, let's move to router 11. I will configure OSPF version 2 in multiple areas. I will configure the routers that have interfaces in area 10 and in area 10 with OSPF version 2. Now on router 11, which is our guy here, enable, configure terminal, router OSPF 10. Next, I will activate routing for the appropriate networks. I will use inverse masks that only addresses within the networks. Then after I'm done, the host on all LANs, when I'm done completely with the video, on all LANs should be able to communicate with each other over IP version 4. But now, on router 11, let's see the networks are connected to this router. Let me run this command, do show IP route connected. Enter. As you can see, we have 3 networks connected to router 1. So now the network of 172.16.10.0 with the inverse subnet mask of 000.3. This is in area 10. And the other network of 172.16.10.8 with the inverse subnet mask of 0003. This is also in area 10. And the other network of 192.168.11.0 with the inverse subnet mask of 000.255. And this is also in area 10. Now I will set the router ID. I'll exit from here. Router OSPF process ID 10. Router OSPF 10. Router ID of this is for router 11 of 10.111. Enter. Now we are done with. Not to worry about this error again. We were done with the router of 11. Now let's move to the other router of 12. Enable, configure terminal. I will use a process ID of 10, router OSPF 10. Next, I will activate the appropriate networks. I will use the inverse masks that specify only addresses within the networks. Now I will run the command to know what networks are connected to our router here on router 12. Do show IP route connected. Enter. As you can see, we have 3 networks here. So the network of 172.16.10.4 with the inverse subnet mask of 0003. This is also in area 10. And the other network of 172.16.10.8 with the inverse subnet mask of 000.3 in area 10. And the network of 192.168.12.0 with the inverse subnet mask of 000.255, also in area 10. Next, I will set the router ID. I'll exit from here and then type the command router OSPF 10. Now, router OSPF 10, router ID of 10.2.2.2. Enter. Next, I will configure router 21. we were done with these two guys here, router 1.1 and router 1.2. Now let's move to this guy here, router 2.1. Enable, configure terminal. I will use a process ID of 10, router OSPF of 10. Next, I will activate routing for the appropriate networks. I will use inverse masks that specify only addresses within the network. So let's see what the networks are connected here. Do show IP route connected. Enter. We have two networks here are connected, this network and this network on our router 2.1. The network of 172.16.20.0 with the inverse subnet mask of 000.3. This is in area 20. And the other network of 192.168.21.0 with the inverse subnet mask of 000.255 in area 20. Enter. Next, I will set the router ID. I'll exit from here. Router OSPF 10. Router ID of 20.1.1.1 and then hit enter. We are done with this guy here. Let's move to router 2.2. Enable. I will use the process ID also of 10. Configure terminal, router, OSPF, process ID 10. Enter. I will activate routing for the appropriate networks. Let's see what networks are connected to router 2.1, which there are two networks. So run this command, do show IP route connected. Enter. We have two networks. The network of 172.16.20.4 with the inverse subnet mask of 0.0.3 in area 20. And I always did a mistake here, network. OR. And the other network of 192.168.22.0 with the inverse subnet mask of 0.0.255 in area 20. Enter. Next, I will set the router ID. Exit. Router OSPF 10. Router ID of 20.2.2.2. Enter. Next, I will check connectivity on the network over IP version 4. So here on PC1, I'll run some pings. The desktop command prompt, I will ping. This is over IP version 4, 192.168.11.20. It should be successful. And the upper arrow, I'll move back, 192.168.12.10. And it is successful. And the upper arrow and backspace and .12.20. Enter. Also, it should be successful. And it is. You can just keep running more pings. You know, I was pinging from here to PCs. You just ping from PC 1.2 to all the PCs. From any PC here, just, you know, have fun, run some pings, and this will show you that your configuration so far over IP version 4, because I still need to work on IP version 6 for the OSPF version 3. Just run more pings, to make sure that everything is working as planned. Next, I will configure OSPF version 3 in multiple areas. I will configure the routers that have all interfaces in areas 10 and 20 with OSPF version 3. So now, on router 1.1 here, back to our guy here, exit. I will configure this IP version 6, enable unicast routing. I will use the process ID of 10. IP version 6 OSPF, IP version 6 router OSPF of 10. Next, I will activate the appropriate networks. First, the router ID of 10.1.1.1, and I'll exit from here. Now, on the interface of serial 000, this is the interface facing router 1, IP version 6 OSPF 10 in area 10, and the interface of gig 00. Enter IP version 6 OSPF 10. This is also in area 10, and the interface of gig 01 IP version 6 OSPF process ID of 10 in area 10. Enter. So I'm done configuring the router 1.1. So now let's move to our guy here, router 1.2. Exit. First, let me enable the unicast routing, IP version 6 unicast routing. I will use a process ID of 10, IP version 6 router OSPF 10. Next, I will activate the appropriate networks. Now, let me configure the router ID. 10.2.2.2. Enter. I'll exit from here, and then on the interface of serial 000, IP version 6 OSPF 10 in area 10. On the interface of gig 00, IP version 6 OSPF 10 in area 10. And the interface of gig 01, IP version 6 OSPF process ID of 10 in area 10. Next, on router 2.1 here. So we are done with this portion of the network, so we'll work on this side. On router 2.1, on the router, I'll exit from here. First, I will enable unicast routing, IP version 6 unicast routing. I will use a process ID of 10. IPv6 router OSPF 10. This is, we are working on router 2.1. Now I will activate the appropriate networks, but first let me configure the router ID on the router of 20.1.1.1. Enter. Now we have the interface of serial 000 on router 2, this interface and this interface. We have two interfaces, serial 000, enter, IP version 6 OSPF, process ID 10 in area. This is in area 20. And the interface of gig 00, IP version 6 OSPF 10 in area 20. Enter. Now I will work on router 2. This guy here. Exit from here. I will enable unicast routing, IPv6 unicast routing. I will use a process ID of 10, IP version 6 OSPF router, OSPF 10. Next, I will activate the appropriate networks. First, the router ID of 20.2.2.2, enter. On the two interfaces connected with router 2.2, which is this interface on serial 000 and this interface on gig 00. On the interface of serial S000, IP version 6 OSPF 10 in area 20, and an interface gig 00 IPv6 OSPF 10 in area 20. Next, I will check connectivity between hosts on all LANs over IP version 6. So on router PC1 here, I will ping 2001 DB8 11 20, and it's successful. So I was pinging from this PC over IP version 6, this guy here. So what you need to do is just run from PC 11 to PC 13 to PC 14, from 11 to PC 21, to 2, to 3, and to 4. And vice versa from PC 24 to any PC here or interfaces you want. You can ping using IP version 4 or IP version 6. Just have some time just to know if your configurations so far are being accurate and correct. Now, I did the configuration of the OSPF version 2 and OSPF version 3. Now I will customize OSPF version 2 and OSPF version 3 on this topology network. For the multi-access network connected between router 11 and router 12, I will configure priorities so that router 1 will become the designated router DR, and router 2 will be the backup designated router BDR. I will use priority of 225 and 200. So now on router 11 here, exit. Now on the interface gig 01, connecting router 11 with router 12. On the interface of gig 01, interface gig 01, enter, and the command goes like this: IP OSPF priority to, let me see, here we are going to use the 255, enter. This is for IP version 4 and for IP version 6, IPv6, OSPF, priority, also of 255, enter. So this is our designated router. So now on router 12, this guy here, exit. On the interface, as you can see, we have here on router 12, the interface of gig 01 connected to router 11. So it's a interface gig 01 for IP version 4, IP OSPF priority of 200, because this is our backup designated router. And for IP version 6, OSPF priority also of 200. Enter. Next, I will configure the interfaces on all routers that are attached to LANs with hosts not to send OSPF version 2 or OSPF version 3 traffic into the LAN. Once again, I'll say it, that I will configure the interfaces on all the routers here on this topology diagram that are attached to LANs. We have these LANs here with host not to send OSPF version 2 or OSPF version 3 traffic into LANs. So on our router, router 1.1 here, exit router OSPF process ID of 10, passive interface, it's on the gig of 00. This is for IP version 4 and for IP version 6, IPv6 router OSPF process ID of 10, the passive interface of gig 00. We are done with this router. So to jump on router 1.2, exit from here. Router OSPF 10, the passive interface on gig 00. This is the interface where we have hosts connected. And IPv6 router OSPF 10, passive interface on the gig 00. Next, on router 2.1 here, exit. Router OSPF of 10, the passive interface on gig 00, and IP version 6 router OSPF process ID 10, the passive interface on gig 00. And finally, on our router 2.2, exit, router OSPF 10, this is for IP version 4, the passive interface on the gig 00, because this is our interface where we have hosts connected, and the other one, configuring IP version 6, IPv6 router OSPF 10, passive interface on gig 00. Next, I will enable all routers to automatically and accurately calculate cost for routers that include 1 gigabit per second Ethernet networks by changing the reference bandwidth. So, on router 0, this guy here, enable, configure terminal, router, OSPF 10. So the default OSPF metric is calculated by dividing the reference bandwidth by the bandwidth of the interface. The default value of the interface bandwidth 10 to the power 8. The default reference bandwidth of OSPF is 100 megabit per second, and the default OSPF cost formula doesn't differentiate between interfaces with bandwidth faster than 100 megabit per second. So now we are still on router 0. So the command goes like this. The auto cost for reference bandwidth is 1000. Enter. Now, IPv6 router OSPF 10, the auto cost, reference bandwidth also of 1000. Enter. Now back on router 1, enable, configure terminal, router OSPF 10, auto cost, reference bandwidth of 1000, IPv6, router OSPF 10, the auto cost, reference bandwidth of 1000. Now, with whatever you see here, it will change when we do finish the configuration. So now we are done with router 1. So now to go to router 1.1. Here, exit, router OSPF 10, auto cost, reference bandwidth of 1000, IP version 6 OSPF, IP version 6, router OSPF 10, auto cost, reference bandwidth of 1000. Now on router 1.2, this guy here, exit, router OSPF 10, auto cost, reference bandwidth of 1000, IPv6 router OSPF of 10, auto cost, reference bandwidth of 1000. This is router 1.2. Now we will go to router 2.1. Here, exit, router OSPF 10, auto cost, reference bandwidth of 1000, IPv6 OSPF, router OSPF 10, auto cost, reference bandwidth of 1000. Now on router 2.2, exit, router OSPF 10, auto cost, reference bandwidth of 1000, IPv6, router OSPF 10, auto cost, reference bandwidth of 1000. Next, I will configure OSPF version 2 and OSPF version 3 so that the default routes that are configured on router 0, on this router here, are automatically distributed to all routers in the network. I will only configure router 0, just this router here. Exit. Router OSPF 10, default information originate, and IP version 6, router OSPF 10, default information originate. Enter. Next, I will adjust the OSPF version 2 timers on the Ethernet link between router 1.1 and router 1.2 for the hello interval 5 seconds and the dead interval for 20 seconds. So on router 1.1, exit here on the interface of gig 01. And the command goes like this: IP OSPF hello interval of 5 seconds and IP OSPF did intervals of 20. This is for IP version 4. Now we are IP version 6. IPv6 OSPF allow intervals of 5. IPv6 OSPF did intervals of 20 seconds. So now I will do router 1, 2. On the interface of gig 0, 1. Interface gig 0, 1. This will change. IP OSPF hello interval of 5. IP OSPF did intervals of 20. For version 6 IPv6 OSPF hello intervals of 5. IPv6 OSPF did intervals of 20. So it changed here, loading is full to full, loading done. So now let me see if I can ping from PC1 to the internet server. Ping 8.8.8.8. And I was successful. So you also, when you are done, when you reach this point in the lab, just from PC1, try from PC1 2, from PC1 3, from PC1 4, and just try to ping the server here on the internet. I hope you learned something from this video. I hope when you do it, it will be fun to do it. Just, you know, like a puzzle, and just follow the walkthrough and do it. And if you like it, please subscribe to my channel, tell your friends about it, and give me the thumb up. If you have any suggestions, comments, or questions, if you are a friend on Facebook, just send me a message. I will definitely answer you back, and I would love to have you as a friend on my Facebook page. Thank you so much for watching, and I will see you soon in my next video. Have a nice day.